In the first example, we're going to identify whether the table of values shown represents a quadratic relation. To do this, we first need to calculate the first differences. So I'm going to draw an extra column here and label it FD for first differences. And then I'm going to determine these first differences by subtracting successive y values. The order in which you subtract them is very important. You have to subtract the first y value from the second y value. So 3 take away 2 gives us 1. Then we're going to subtract the second y value from the third one. So 6 take away 3 is 3. Now we have 11 take away 6, which is 5. And then 18 take away 11, which is 7. So these are the first differences, and next we're going to calculate the second differences. And we're going to figure out the second differences in the same manner that we did the first differences by subtracting the values in this last column. So 3 take away 1 is 2. 5 take away 3 is 2. And 7 take away 5 is 2. We see that the second differences are all the same. Because the second differences are the same, we know that this table of values represents a quadratic relation. This is a quadratic relation. Okay, let's move on to the second example here. In the second example, it says that each table of values represents a quadratic relation. We need to decide whether the parabola that is represented by each table of values opens up or down. To do that, we again have to determine the second differences. The sign of the second differences will tell us the direction of opening. So I'm going to calculate the first differences by subtracting successive y values like I did in the first example. So 2 take away 1 is 1, 9 take away 2 is 7, 22 take away 9 is 13, and 41 take away 22 is 19. Now for the second differences, 7 take away 1 is 6, 13 take away 7 is 6, 19 take away 13 is also 6. So as can be expected, all the second differences are the same because we were told the quadratic relations are represented by the table of values. However, because the second differences are all positive, we know that the parabola will have to open up. Okay, let's look at part B here. We're going to calculate the first differences again and the second differences. I'm going to extend my table here. So 1 take away negative 3 is the same as adding 3 to 1, so it's 4. 3 take away 1 is 2. 3 take away 3 is 0. 1 take away 3 is negative 2. Now subtracting the first differences. 2 take away 4 is negative 2. 0 take away 2 is also negative 2. And negative 2 take away 0 is negative 2. In this case, the second differences are negative, indicating that the parabola opens down.